Hello everyone, welcome back to DMG chemistry classes and myself Dr. Mahendra Guleria, Associate Professor in Chemistry. And in this video, I am going to discuss some very important and interesting characteristics of electromagnetic radiations. So keep watching this video till very end and also like and share my videos and subscribe my channel. Okay? So the first characteristic which I am going to take up is wavelength. So what is wavelength? So it is the distance between adjacent crests or troughs. Okay, so let us understand that what do we mean by a crest and trough. So we know that a wave propagates in this manner and these upward half cycles are called as crests, whereas these downward half cycles are called as troughs. And distance between these adjacent crests or adjacent troughs is called as wavelength. So these are the adjacent crests, okay, and this distance, and the wavelength is represented by a Greek letter lambda. So this distance is wavelength, or this distance, that is distance between adjacent crests and adjacent troughs, is the wavelength. Understood? And this distance, okay, or this distance is called as amplitude. Amplitude or amplitude of the wave. Understood? Further, the wavelength can also be defined in another way, that it is the length of successive crest and trough. Successive mean to say साथ साथ वाले, crest and trough. So here this is crest and this is trough, and both of them are successive. Then this length, okay, this length will be equal to lambda, and we can easily understand that this length and this length is same. Let us suppose that this distance is 10 centimeter, then this distance will also be equal to 10 centimeter, then the wavelength, that is this distance, will be equal to 20 centimeter. Understood? And here also this distance will be equal to 10 centimeter, then this distance will be equal to 5 centimeter in this side and 5 centimeter in this side. So here also the total distance, that is the wavelength, it is equal to 10 plus 5 plus 5, and it is equal to 20 centimeter. Understood? So both these definitions are same. Okay, and further it represent one wave cycle. So it is called as one wave cycle or one wave. Okay, one wave cycle or one wave cycle, CYCLE. Okay, and the length of one wave cycle is equal to wavelength, that is lambda. And this is going to be very helpful in understanding the remaining characteristics of electromagnetic radiations. Understood? So this is one wave cycle. And the wavelength is expressed in terms of angstroms, microns, millimicrons and nanometers. So these are the units of wavelength. And 1 angstrom is equal to 10 raised to power minus 10 meters or 10 raised to power minus 8 centimeter, because we have multiplied it by 10 raised to power 2. And 1 micron is equal to 10 raised to power minus 6 meter or 10 raised to power minus 4 centimeter. And 1 millimicron will be equal to 10 raised to power minus 9 meter, because to convert micron into millimicrons we have to divide it by 10 raised to power 3. So that's why 1 millimicron is equal to 10 raised to power minus 9 meters or equal to 10 raised to power minus 7 centimeters. And 1 nanometer, it is equal to 10 raised to power minus 9 meter. And what we have done here, I have multiplied it by 10 and divided it by 10. So after multiplying and dividing by 10, we will have 10 into 10 raised to power minus 10 meters, and 10 raised to power 10 meters is equal to 1 angstrom. So 1 nanometer is equal to 10 angstroms. Understood? So these are the various units in which we will express wavelengths. Understood? So now the next characteristic which I am going to discuss is time period. Okay? Time period. So what is time period? Time period is the time taken by the radiation to complete one wave cycle. Okay? So the time taken by the radiation to complete one wave cycle. One wave cycle is called as time period, and it is represented by the symbol capital T. Okay, and I have explained that what is one wave cycle. And the next characteristic is frequency. So frequency is defined as it is the number of waves or wave cycles. It is the number of waves or wave cycles passing through a point in 1 second. In 1 second. Okay? And suppose we have a point here, and if the two cycles are passing through this point in 1 second, here we have, this is your one cycle, this is your one cycle, and this is your second cycle. Okay, so if through this point in 1 second two cycles are passing, then the frequency will be equal to 2 cycles per second. And if we have another cycle here in this way, now how many cycles are passing through this point in 1 second? 3 cycles. Then the frequency of the wave will be equal to 3 cycles per second. Understood? And the frequency is represented by the Greek letter nu. Understood? And the units of frequency will be equal to cycles per second. Okay? And we can also define frequency in terms of time period. As I said, that time period is the time taken by the wave to complete one cycle or one wave cycle. So if time period is t seconds, then in t seconds how many cycles wave cycles will be completed? One wave cycle will be completed in t seconds. Then in 1 second how many wave cycles will be completed? So in 1 second 1 upon t wave cycles will be completed, and the wave cycles completed in 1 second is what? Is frequency. Understood? So the nu is equal to 1 upon t. So we can also define frequency in a way that it is the reciprocal of the time period. Understood? So now let us discuss velocity of the wave. Velocity is the linear distance. Velocity is a linear distance traveled by a wave in 1 second. Okay? So velocity is, or it is the linear distance traveled by wave in 1 second. Okay, and this velocity is represented by c, and this c is equal to nu into lambda. C is equal to nu into lambda, where nu is the frequency and lambda is the wavelength, and its units are centimeter per second or meter per second. Okay, and we can easily understand that how this expression has been derived, that y c is equal to nu into lambda. So here the frequency is equal to nu. Okay, this means that how many cycles the wave how many wave cycles are passing in 1 second equal to nu. Okay, so number of wave cycles passing in 1 second is equal to frequency, that is nu cycles. Okay, and if we can calculate the length of these nu cycles, then that would be the distance traveled in 1 second, and the distance traveled in 1 second will be what? Velocity. Understood? And I have told you that what is the length of one wave cycle? The length of one wave cycle is equal to lambda, that is wavelength. So the length of one wave cycle is equal to lambda centimeter. Understood? Then length of nu cycles or nu wave cycles will be equal to what? Nu into lambda. So we have calculated the length of nu cycles. So length of nu cycles will be equal to nu into lambda centimeters. Okay, and this will be the distance traveled by the wave in 1 second, that is velocity. So that's why this is c is equal to nu into lambda. Understood? So this is the velocity of the electromagnetic radiations. Next we are going to discuss wave number. Wave number. So what is wave number? Wave number is the number of waves present in 1 centimeter, or it is simply the reciprocal of wavelength. So wave number, it is the number of waves present in 1 centimeter or it is reciprocal of wavelength. Okay, and I have told you that one wave cycle is also called as one wave. Okay, so the length of one wave cycle or one wave is equal to what? Lambda. This means that in lambda centimeters we have how many waves? We have one wave. Okay, then how many waves we are going to have in 1 centimeter? So in 1 centimeter we have 1 upon lambda waves. Okay, and the number of waves in 1 centimeter is called as what? Wave number. And wave number is represented by the symbol nu bar. And this is equal to 1 upon lambda. Understood? So that's why this wave number is the reciprocal of wavelength. Understood? So these were the various characteristics of electromagnetic radiations. And I am also going to discuss electromagnetic spectrum here. So let us discuss electromagnetic spectrum. electromagnetic spectrum. Okay. So it is the arrangement of all electromagnetic radiations in the increasing order of wavelengths or decreasing order of frequency. Okay. When we will arrange all the electromagnetic radiations in increasing order of wavelength or decreasing order of frequencies, then we will get electromagnetic spectrum. Okay. So let us write, that is, it is the arrangement of all electromagnetic radiations in the increasing order of wavelengths or decreasing order of frequencies. Okay, so in this order, first of all we will have cosmic rays. So here we have cosmic rays, then we will have gamma rays, then we will have X-rays, then ultraviolet rays, visible rays, then IR, infrared rays, microwaves, and finally we have radio waves. Okay, so here we have arranged all the electromagnetic radiations in the increasing order of wavelength. So this is the increasing wavelength. Okay, or decreasing frequencies. Okay, so here cosmic rays are going to have minimum wavelength and maximum frequency, and radio waves are going to have maximum wavelength and minimum frequency. Understood? So this arrangement is called as what? Electromagnetic spectrum. Further, energy of any radiation is given by this expression, that is E is equal to h nu, and we know that C is equal to nu lambda, and from this nu is equal to C upon lambda. Okay, so we will substitute it here, then we will have E is equal to hc upon lambda. So these two are the expressions for the energy of any electromagnetic radiation. So the energy is directly proportional to the frequency. If the frequency of electromagnetic radiation will increase, energy will increase, and energy is inversely proportional to the wavelength, and if the wavelength increases, energy decreases, or vice versa. Understood? And here, because the frequency and wavelength, they are also inversely related to each other. Okay, if the wavelength increases, then frequency decreases, and vice versa. Understood? So this is all about the various characteristics of electromagnetic radiations and electromagnetic spectrum. Understood? So please keep watching my videos, and also subscribe my channel and like and share my videos. Thank you very much.